All right, we're doing linear and quadratic functions and modeling. So we're going to look at polynomial functions, linear functions and their graphs, average rate of change. I don't know why that did that, and so on. Okay, a polynomial function. So if we have different terms like a to the 0, a to the 1, a to the 2, and so on, a polynomial function f of x equals a to the n, x to the n, a to the n minus 1, x minus 1, and so on, where the leading coefficient is your coefficient of your highest degree term. And your highest degree term is the variable with the highest exponent. A zero function is a function which equals 0. Okay? It has no degree or no leading coefficient. So, a zero function is just 0. A constant function, f of x equals a. Its degree is 0. Its leading coefficient, well, there is really no leading coefficient because there's no x involved. A linear function is a to the x plus b, or most of you have seen mx plus b. Hello. Yeah, yep. We have to cap it after that, yep. 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 Yep, bye. Okay, a quadratic function has a degree of 2 because the highest degree power is 2, and the leading coefficient would be a there because that's in front of the highest power. So each, yes.
Wait, why wouldn't the constant one have 1 though? Since there's 1 power.
What do you mean? There is no power because a is a constant, not a variable. So it's like f of x equals 2.
Yeah, but isn't that to the first power though?
2 is to the first power, but there's no variable to power there.
Oh, okay.
So we're talking about the degree is the variable, the degree of the variable, not the degree of the constant. Okay? So you have a constant function, linear function, quadratic function. So let's look at a linear function. Now, this is more complicated than what it needs to be. This is the x value, this is the y value. So really this is the ordered pair 1, negative 1, 2. And the ordered pair 2, 3. How do we write an equation? Well, first we find the slope. Well, how do we find the slope? Well, you go y2 minus y1 over x2 minus x1, which is 1 over 3. There's my slope. Here's my point. I put it into, if I have a point and a slope, point-slope form. Which is y minus y1 equals m times x minus x1. So y minus 2 equals 1/3 times x minus a negative 1. Now, you have to be careful on Math Excel because sometimes it'll ask for point-slope form, you get it this far, and you stop. If it asks for the equation in slope-intercept form, then you keep going.
Wait, where did you go?
Where did I get out of this?
Yeah.
What do you mean?
Like, how did you get that function? That formula, you know?
That formula?
Or that equation?
From point-slope form. This is x1, y1, and we found our slope over here. And we just plugged the numbers in. This is y1, plugged it in there. This is x1, plugged it in there. This is our slope, plugged it in there. Okay, point slope form is what I used. This is all kind of review from in the past, and I don't know what I just did. Oh, that was cool. If I hold the screen with my finger, now it won't do it. So if you're told to put it in slope intercept form, distribute. So y minus 2 equals 1/3 x plus 1/3, and then add 2. 2 is how many thirds? 6/3. So y equals 1/3 x plus 7/3. There's your equation. There's your linear function. And actually, to be in function notation, f of x equals 1/3 x plus 7/3. That would be in function notation. Okay? So, writing a linear function. And they wind up with the same answer I got. Average rate of change is also known as slope. Okay? Because this is y2, this is y1, this is x2, this is x1. So when you're finding the average rate of change, you're basically finding the slope of the function. We're not going to worry about a constant rate of change theorem. Basically, a constant rate of change is a horizontal line. All right. A linear function is a degree of 1, y equals mx plus b. The slanted line is the slope. The y-intercept where it crosses the y-axis is b. Okay, this is just basic. I'm not going to worry about this stuff on a quiz or test. It's, do you know how to use y equals mx plus b? That's what I'm worried about. All right. This is the second part, I think. So let me scoot out of this. And then PreCalc. Section 2, 2.1a. Boom, boom. All right. Is this a polynomial function, 8x to the negative fifth plus 11? Most of you'd say, yep, sure it is. But the problem is, this is 8 over x to the fifth plus 11. So it is not a polynomial function because we're dividing by a variable. When we divide by a variable, it is not a polynomial function. Okay? Do not divide by variables. It is not a polynomial function if you divide by a variable. You can divide by a number, but not a variable. Is this a polynomial function? Yep, it is. What's the degree of the function? What's the highest power that appears? The fourth. What's the leading coefficient? 5 is the coefficient of the leading term, of the highest power term. Okay? All right. When you see this notation, that's the ordered pair -4, -1. This is the ordered pair 2, 4. If we graph those, -4, -1, and 2, 4, we align like that. What's the equation of the line? Well, we rise 1, 2, 3, 4, 5. We run to the right 1, 2, 3, 4, 5, 6. So our slope is 5/6. Now it looks like we crossed right at 2, but to be sure, we're going to put it in point slope form and solve. So y minus the y value, -1, equals 5, 6 times x minus the x value, -4. So each time we'll go plus a positive. So y plus 1 equals 5, 6 x plus 26. What's 26 the same as? 10 over 3. 20 over 6 is the same as 10 over 3. Then we're going to subtract 1 from each side. Well, subtracting 1 is the same as subtracting 3 over 3 if we get a common denominator. So our function is y equals 5, 6 x plus 7/3. Now, my graph looked like it crossed at 2. My graph was a little off. My line wasn't perfectly straight. So f of x equals 5, 6 x plus 7/3. There's my function. Just replace the y with an f of x. We have the points 0, 5, and 5, 0, which makes writing a function really easy. 0, 5, 5, 0. What's the slope of this line? Not 1, but -1. What's your y-intercept? 5. So f of x equals -x plus 5. There's your function. Easy peasy lemon squeezy. Now if we have a quadratic function, this makes it 3 times skinnier. And your vertex will be at HK. The opposite of this, the same as this. So in this one, your vertex is at -1, 5. And instead of going over 1, up 1, over 2, up 4, it's going to go over 1, up 3, over 2, up 12. So it's going to be a skinny one going up at -1, 5. Well, A is the only one that makes sense. Now, I want to take the vertex form here and put this into vertex form. How do I do that? Well, I just change it by saying -3 x minus 1 squared plus 3. Where's your vertex? What's the ordered pair of your vertex for this one? 1, 3. The opposite of this, the same as this. So your vertex is at 1, 3. Is it going up or down? Down, because it's a negative, and it's 3 times skinnier. So it's skinny going down at 1, 3. So at 1, 3, which one is at 1, 3? Well, I think this one is at 1, 3. And it's skinny, and it's going down. I don't know how skinny it is, but, I guess it's skinny. Okay. So find the correct graph is a parabola with a vertex at, well, no, 1, 3. In addition, the graph opens down and passes the points 0 something and 2 something. So how can we figure out what it passes through? Well, you plug it into the equation. So we're going to plug 0 into this equation here. So if we plug 0 in, 0 minus 1 is negative 1. Negative 1 squared is 1. 1 times negative 3 is negative 3. Negative 3 plus 3 is 0. So 0, 0 is a point. If we put in 2, it's 2 minus 1. 1 squared is 1 times negative 3 is negative 3 plus 3 is 0. 2, 0 is also a point. So 0, 0, 0, 0, and 2, 0. Okay? Graphs of parabolas. So you'll have a couple of those. And then they'll say, hey, how does this graph compare to this graph? Well, what's the vertex of the new one? This is the new one. What's the vertex of the new one? Negative 2, 2. The opposite of this number, the same as this number. Negative 2, 2. So it goes there. And there's a 1 in front of here. So it kind of looks like this. Because it goes over 1, up 1, over 2, up 4. Same as this one would. Okay? So it's shifted to the left by 2 units, and it's shifted up by 2 units from the original, because the original is x squared. I think you can handle that one. All right. So it says, complete the square to do this. Ooh, completing the square, that's a good old Algebra 2 thing. How do we complete the square? Well, this is how we do it. We take x squared minus 6x plus blank plus 11 minus blank. Okay? So this is going to be its own thing. This is going to be its own thing. Okay? So how do we complete the square? We take half of this number and square it. What's half of negative 6? Negative 3. Negative 3 squared is? Whatever we add to here, we subtract from here. So this is x minus 3 quantity squared plus 2. We completed the square. Okay? So we take, what we do is we shift this over, and we add a blank in its place, and then we're going to, whatever we add to it, we're going to subtract from this number. Now that we've got that, the vertex is at where on this one? 3, 2. Okay, it's a parabola with an axis of 3, 2. The axis of symmetry is always x equals the x value of the vertex. The axis of symmetry is always x equals the x value of the vertex. To find your x-intercepts, set the function equal to 0. To find the x-intercepts, set the function equal to 0 and solve. Now, if you solve this, x minus 3 squared equals negative 2. If we take the square root of each side, what's the square root of negative 2? What's the square root of negative 2? It's some imaginary number, right? It's not a real number. So will it have x-intercepts? No, it will not. Let's do another one, completing the square. Okay, this one has a negative at the start. So what I'm going to do is pull out the negative first and go x squared plus 6x minus 51. Okay? So then it's negative 1 times x squared plus 6x plus blank. And then if I pull the negative 51 out of the parentheses, it becomes positive 51 again. Because a negative 1 times a negative 51 becomes a positive 51. Okay? So then I'm going to subtract blank, which is really, I'm going to add blank because there's a negative 1 involved. The negative 1 really confuses things. Okay, what's half of 6? 3 squared is? So if I go a 9 there, I'm going to go a 9 here. And why did I add 9? Well, this is really a negative 9 over here because the negative 1 on the outside. So this is negative 1, x plus 3, quantity squared, plus 60. Negative 1, x plus 3, quantity squared, plus 60, which is, again, choice A. The graph of the function, well, it's a, I don't even know what they want in number 1. Oh, it's in, does it open up or down? Down, because there's a negative sign in front. So downward opening. With a vertex, where is the vertex? Negative 3, 60. It will have some x-intercepts this time, and you'll have to find those. Okay. So if we go negative x plus 3 quantity squared plus 60 equals 0, then negative x plus 3 quantity squared equals negative 60. So x plus 3 quantity squared equals a positive 60 if we divide both sides. We take the square root of both sides. X plus 3 equals plus or minus the square root of 4, the square root of 15. So x plus 3 equals plus or minus 2 square root of 15. So x equals negative 3 plus or minus 2 square root of 15. There's your x-intercepts. And that is that. Okay? So this will take you at least till lunch to do. It is out there for you already, so you can get started on it.